Okay, so y is less than or equal to 4. Y equals is a horizontal line. X equals is a vertical line. So y is less than or equal to 4 is a horizontal line up here at 4. X equals -1 is right here, and it's a dotted line because of that. You don't have to test a point here. So you don't have to test 0, 0 on these points. For less than a horizontal, it's simply down here. For greater than a vertical, it's this way. And therefore, that's why this is the highlighted area. For number 2, simple one to graph with slope-intercept form. -1 is my intercept. Up 1, right 2 is my line. Down 1, left 2 is my line. And it is a dotted line. I can test 0, 0. And I get a true statement. And therefore, that's why I'm shading up this way. The second line, also dotted, goes through 4, which is up here. It also has a 1/2 slope. So it's a parallel line. They both have the same slope. This line is up here. Well, when I test 0, 0, I get a true statement again. But since 0, 0 is underneath it, I shade this way. And the overlapping area is where they cross in between the two lines. On number 3, y equals -x is this line right here. Okay, it goes through 0, 0, has a -1 slope. Down 1, right 1, up 1, left 1. I can't test 0, 0, so I test some other point. I pick 3, 3. When I plug 3, 3 in, I got a true statement, which means if 3, 3 is up here, I shade that way. The next one goes through -1. It has a steeper slope of 3. It's a solid line like this. I missed a little bit. When I test 0, 0, I got a true statement, so I shade this way. The overlapping area is up here. Number 4, this one's a kind of a different one. On number 4, when I shade this one, I want to do this line. It's this dotted line right here. I'm sorry about that. It's a solid. It's this dot. This should be dotted. I got it backwards. So this should be dotted, and this should be solid. So the -4 intercept is down here, and I get a true, a false statement. Okay. So I'm not going to shade there. This one, I get 0 is less than 1. True statements. Okay. And so they actually overlap each other, so the shaded area is up here where they overlap. So that there's both up and left of both lines. Now, -4, 7. Where's that? Well, -4, 7 is going to be somewhere up here, not in the shaded area. 0, 0 is right there, so yes, that's in the shaded area. It's the solution. -1, 4 is up here. It is a solution because it's in the shaded area. And 10, 0 is out here, so no. Number 5 goes through 2. It has a -3/2 slope. So down 3, right 2, down 3, right 2, up 3, left 2, and so forth. So there's my line. The second line is a horizontal line through 2, y equals 2. So my point of intersection is right there at 0, 2. Number 6, I'm going to move this over and put it in slope-intercept form. It becomes 2x plus 5. Since it's 2x plus 5, it has the same slope. One going through 3, one going through 5. They will never cross. No solution. Number 7, it's screaming for you to do substitution. So we substitute in right here. We end up with the statement 16 equals 6, which is false, so no solution. Number 8 is also screaming for you to do substitution, so we put it in right there. We end up getting y is 3. Plug 3 back into the original equation here. Be careful that you keep this negative there. It's the opposite of y, so -3 plus 5 is 2. And we do write that as a point, 2, comma 3. It says use elimination. Well, the easiest thing to do is just to turn this into a positive 6 to cancel with this negative 6. So I did that. 2 times 3 is 6, 2 times negative 2 is negative 4, and 2 times 1 is 2. The x's cancel, but the y's cancel also. So I get 0 equals 10, which is a false statement. No solution. On number 10, I have a choice. The x's can cancel with 10 and negative 10. The y's can cancel with 40 and negative 40. Most people usually pick the smaller number. So to do that, I multiply by 5 and negative 2. If you multiply by negative 2 and positive 5, that works. It just flip-flops them. Okay? So 5 times 2 is 10, 5 times 4 is 20, and 5 times 6 is 30. I get negative 10, negative 20, negative 30. In this case, everything drops out no matter which one you did, so you get 0 equals 0. That's a true statement, and it gives you infinite solutions. So infinite solutions can be a true statement. Okay, the sum of two numbers is 10. You just literally write that, and you define your variables. Okay, this is going to be on the test. You have to do this part. You have to define your variables. So my first number is x, second number is y. This really helps you when you're translating this. Not for this part. Two numbers add 10, no big deal. Number plus a number equals 10. But in the second one, it's important. 2 less than 3 times the first number. That's why you got to know which letter is your first number. Now, almost everybody wanted to do this. Okay? Common mistake, we've been talking about this for weeks. It says 2 less than something else. This 2 is not less than 3x. The 3x is less than the 2. Okay, you got to think about what it means. If you see less than, that means this 2 is less than something in front of it. That's why it's 3x minus 2 and not 2 minus 3x. And then it says is equal to the second number. That's why it's important to know what x and y is. This is begging for you to do substitution. So when you do that, you get x is 3, plug it into the original equation for the easiest, quickest answer, and you get 7. And you get 3 and 7 as your two numbers. Okay, a lot of people use G and P. I use X and Y, but you can use G and P, that's fine. So I got glitter and plain. There's two types. They both add up to 37. There's a total of 37. The value of the glitter is $7.5. The value of the cost of the plain is $5. And this is the total money raised. Well, as I said before, you can choose to cancel the 5 or the 7.5. I find it easier to cancel the smaller number, so I multiply the entire first line by negative 5. Which gave me negative 5x, negative 5y, and 37 times negative 5 is negative 185. When I combine them, the x's drop off. I'm sorry about that. The y's drop off, giving me 2.5x equals 30. When you divide by 2.5, you get 12. That means there's 12 rolls of glitter. All you have to do is pop the 12 bit back in here and find out that there were 25 rolls of plain. There was more plain, it was cheaper. And again, this is required. The instructions remind you, but I need word answers. 12, 25 will not suffice. 12 and 25 won't suffice. The only reason 3 and 7 work for up here is because after two numbers. Technically, you should say 3 is the first number, 7 is the second number, but I can be lenient there. But the word problem means word answers. Okay, this one is one of those ones where you're comparing two value statements. Okay? Okay, so I use B and D for this one instead of X and Y. I actually went with the letters. This is comparing two situations. Look how easy this is. Just read the line. 10 vans and 4 buses, 328 students. 5 vans, 11 buses, 587 students. This is not a good substitution problem. This is great for elimination. Also, you gotta choose whether you want 10 negative 10 or 44 negative 44. The easiest one is 10 negative 10 because you already have 10. You just need to make this negative 10. We do that by multiplying by negative 2. That gives us negative 10, negative 22, and negative 1174. I write the original equation underneath it. The b's cancel. I end up with negative 18b equals negative 846. Divide, I get 47. I didn't have room in here, but you plug it back in. You get 47 on the bus, 14 on the van. Last but not least, okay, again, you're comparing two situations. You got pecans and chocolate. So you just read it. 10 pecans, 8 chocolate for $282. 2 pecans, 11 chocolate for $235. You're comparing two situations. Again, this is a nice one because it's either 88 and negative 88 or 10 negative 10. And since 2 goes into 10, again, we just multiply by negative 5. That gives me negative 10p, negative 55c, and negative 1175. When I combine, it's okay. I get negative here and I got a negative there. And when I divide by negative 47, I get 19. And when you plug the 19 back in, you get 13. So it was $19 for chocolate cheesecake and $13 for pecan cheesecake. That's it.